Hello, and in this video we're going to take a little bit of a different track. We're going to derive a derivative formula based on facts we already know. So here we have f of x equals a to the x. So a could be any base, it doesn't have to be e. But we're going to use the fact that we know the derivative of e to the x to find the derivative of a to the x. So the first thing to realize is that e to the natural log of a is equal to a. That's one of the logarithm properties discussed way back in Unit 1. And we're going to replace a with e to the natural log of a. So we have e to the natural log of a raised to the x. And then by properties of exponents, we know that that's equal to e to the natural log of a times x. So all three of these things are equivalent, and that's going to be important later on in the problem. So we know that the derivative of e to the u is e to the u times the derivative of u. And we're going to use that fact to find the derivative of this expression. So we have f prime of x is equal to, now remember, this natural log of a is basically just a constant. So we're going to use that when we find our derivative. So that means the derivative of e to the natural log of a times x is e to the natural log of a times x, e to the something, times the derivative of the something. Okay, so that's equal to, now I'm going to leave this the way it is, e to the natural log of a times x times, now remember, this is a constant. So that means we're basically taking the derivative of a constant times x, and that is just the constant. And now to finish this off, remember that e to the natural log of a times x, which is right here, is equivalent to a to the x. All three of those things in the first three lines are equivalent. So I'm going to rewrite that as a to the x because, one, it's simpler, and it's related to what was written as the primary function, which was a to the x. So that means that the derivative is a to the x times the natural log of a.